to Biogan! I am your co-host, Photosynthsis Live! And I am also Cellular Respiration! So, what are we going to be talking about this episode of Biogan? Today we're going to be talking about photosynthesis and cellular respiration. To start out, we got CO2 and water. The CO2 and water come into the plant. The plant steals the sunlight. Yes, it is colored. Moving on, then we got cellular respiration. Where do those things come from? Glucose and water. Moving on. This is a plant. All you need is some sunlight, some carbon dioxide, and some H2O water. Next, we got cellular respiration. You need a human being. Ha. Number 2, you need to breathe in. And number 3, you need glucose and carbohydrates. God damn, put it beside the hook. Come
on. Excuse me, Biogang, what about the similarities and differences of the production of ATP?
Well, what you know about photosynthesis, there can be so many hydrogens, ain't nobody know how many different type of ATP molecules can be made. So I don't know. For cellular respiration, it is very different. We got the theoretical yield of ATP, which is 38. Then we got the real yield, which is 30 to 32. Sunbreak!
Excuse me, Biogang, what about the requirements of sunlight?
With photosynthesis, we're plants. Of course we need the light. For cellular respiration, we don't need sunlight whatsoever. We just need food and water and oxygen. Bam!
Hey, Biogang, what are the steps of each process?
Well, when we're talking about photosynthesis, plants are goddamn lazy bums. We only have 2 steps, light reactions and dark reactions. In the light reactions, you get light from the sun over here. And then you come over here, you get some water, electrons from the water, come out, pump some hydrogens, and are donated to an energy pH by the end of the cycle, and then you got some ATP from there. And then you have a second process, which is the dark reactions, which just takes the CO2, carbon dioxide, and fixates it somehow into glucose. Nice. Glucose, the start of cellular respiration. Number 1, you got this glucose. After it goes through the process of glycolysis, we end up with 2 pyruvates. 2 pyruvates, right? They go through another process. This process is pyruvate oxidation. Pyruvate oxidation leads to another cycle. This cycle is the Krebs cycle, yielding CO2, NADH, and FADH. NADHs go on to the electron transport chain. The electron transport chain yields something very, 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 very important. ATP!
Unfortunately, due to some unknown circumstances, Major Platoon Officer Cellular Respiration and Photosynthesis Man have grievously passed away. We are now joined by 2 professionals.
And this concludes our music break.
There are numerous differences between photosynthesis and cellular respiration. Now, what are these differences? Whilst during cellular respiration, oxygen is absorbed and CO2, however, is released. Now, what is this oxygen and where is this oxygen coming from? It comes from the plants and photosynthesis. Photosynthesis particularly lets out oxygen and takes in that carbon dioxide. Take, however, this aloe vera plant. This aloe vera plant is a key example of letting out this oxygen into the air, where its fate goes to 6 billion human beings to absorb. And that's how we are here breathing today. With multiple research experiments and numerous discoveries made by me and my team, we have won so many participation awards and grade 2 science fairs, which we are very proud of. Thank you. Hello, and welcome to Bioscience. As my partner has talked about, the differences between photosynthesis and cellular respiration. Quite simply put, photosynthesis is for plants, and cellular respiration for us human beings, or other mammals, warm-blooded. Now, what are the differences? Well, there's a clear difference in how they make energy. So why don't we look at their energy powerhouse? Here, we have an aloe vera plant, and preloaded is an animal blood cell. Now, why don't we automatically see from this microscope onto the screen what the differences are? Come on. So, we've just loaded up here the blood cell. Now, as you can see, this is the animal cell. The shape, quite interesting. Highlighted here is the nucleus. And now, we put in a different sample. And now, we go and we load that sample. As you can see, the plant cell is much different. And now we have a screenshot from the last one. And you see this circular shape. See the nucleus in the middle? And again, the shape of a plant cell. Now, importantly, these are their basic structures. They look very similar. And as my partner has said, we live in this beautiful symbiotic relationship with one another. One feeding off the other. One doesn't want the oxygen. One needs the oxygen. One doesn't want the carbon dioxide. The other needs the carbon dioxide. It's beautiful, isn't it? It is. Now, come. Let us look at the beauty. This here, in animal cells, in cellular respiration, is a mitochondria. Beautiful, isn't it? And now this is a chloroplast in plant cells. And you both see that they both have two layers, two lipid bilayers. And again, two lipid bilayers. Protecting it, and on the inside, we see the creation is so beautiful, so scientifically proven to increase surface area for more reactions to take on the surface. And here, more surface area on each of the thylakoid membranes for more and more reactions to take place. The beauty is the fact that they're so similar, but they're so different at the same time. Thank you.